We will continue our study of functions by looking at how to operate on functions. This is also known as function algebra. If we consider the function y equals f of x, we know that for any c in the domain of f of c is a real number. Well, as we know, we can operate on real numbers. We can add them, subtract, multiply, divide. So it would make sense that we can do the same basic arithmetic operations on a function. In fact, we can. So if we let f and g be functions with domain df and dg respectively, the scalar multiple of f and a real number c is cf of f. Right? So the function itself is called cf. And this is just simply the constant c times the function f of x. And its domain is the same as the domain of f. The sum of f and g is the function f plus g. And it is just f of x plus g of x. So you just add the two functions together. And it has the domain d of f unioned with d of g. So it's the union of the two domains. The product of f and g is the function fg. And it's just f of x times g of x. So we just multiply the two functions together. And it has a domain as the same as the sum. It's just the domain of f union domain of g. The quotient of f and g is the function f over g, and it is f of x over g of x. So you just divide f by g. Its domain is the union of the domain of f with the domain of g minus any element in the domain of g that makes g of x 0. Notice that I didn't do a subtraction. We can define subtraction. F minus g as f plus minus 1 times g. Right? So then in this sense, the difference between a combination of sum and scalar multiplication. So let's take a look at doing some of these operations as well as determining domains. So f of x is x minus 1, g of x is x squared minus 1. We will find g plus f, g minus f, g times f, and g over f, as well as determine the respective domains. All right, so g plus f of x. Remember, this is g of x plus f of x. So it's x squared minus 1 plus x minus 1. And so we have x squared plus x minus 2. Now for the domains, first notice that the domain of f is all real numbers. The domain of g is also all real numbers. So if we take their union, the domain here would also be all real numbers. So for g minus f, remember this is the same as g plus minus 1 times f. So g of x plus -1 times f of x. So it's x squared minus 1 plus -1 times x minus 1. So it becomes x squared minus 1 minus x plus 1, and we're left with x squared minus x. And the domain is again the union, so it's all real numbers. So we move on to the product. To do that, I'm going to clear this slide. So we now look at gf of x, which is just g of x times f of x. So it's x squared minus 1 times x minus 1. And we learned how to do this in algebra. We do it using the FOIL technique. Remember that? So we're going to wind up with x cubed minus x squared minus x plus 1. And the domain is once again real numbers. We finally look at g over f of x. So this is simply g of x divided by f of x. So we get x squared minus 1 over x minus 1. This, of course, can be simplified. Remember, x squared minus 1 from algebra is x plus 1, x minus 1. So we could write this as x plus 1. Now the domain would be all real numbers minus those values in the domain of G that make G 0. Well, in this case, G of x is x minus 1. So where is x minus 1 0? At x equals 1. So we have to take x equals 1 out of all real numbers. So the domain becomes negative infinity to 1 unioned with 1 to infinity. This is a new operation for us. It's called the composition. So since f of c is a real number for any function f and any c in the domain of f, we can use it as an input value for another function, say g of x. So long as f of c is in the domain of g. So when the output of one function is used as the input of another function, we call the entire operation a composition of functions. So for any input x and functions f and g, this action defines what's known as a composition function, which we write as f, this open circle thing, g, such that f of g is f evaluated at g of x. The domain of the entire composite function is all the elements of the domain of g that put g of x in the domain of f. So given the functions, f of x is 2x plus 1, g of x is 3 minus x, we're going to find f of g of x as well as g of f of x along with the respective domains. So first we'll look at f of g of x. Well, this is f of 3 minus x, right? Because g of x is 3 minus x. So now we get 2 times 3 minus x plus 1. 6 minus 2x plus 1. We wind up with 7 minus 2x. So that is our composition f of g. The domain, well, since the domain of f was all real numbers, as was the domain of g, right? We have to do all of the real numbers that make 3 minus x a real number. Well, that's all real numbers. Now for g of f. So this is g of 2x plus 1. So we get 3 minus the quantity of 2x plus 1, and we wind up with 2 minus 2x. So that is the composition g of f. And once again, the domain is all real numbers that make 2x plus 1 a real number, which is all real numbers. Now, an important thing to notice here, right? F of g was 7 minus 2x. G of f was 2 minus 2x. Notice that f of g does not necessarily equal g of f. Right? We've lost commutativity. The order in which you do the composition of functions matters. Let's now look at the functions 5 over x minus 1 and 4 over 3x minus 2. We want to find f of g and determine its domain. Okay. Let's first notice the domain of f is everything except 1. Domain of g is everything except 2/3. So now let's find f of g of x. So it becomes f of 4 over 3x minus 2, which is 5 over 4 over 3x minus 2 minus 1. Now let's simplify this. So I have 5 over 4 minus the quantity of 3x minus 2, all over 3x minus 2. So it's 5 times 3x minus 2, all over 6 minus 3x. And we can simplify that even further if we wish. So we have 5 times 3x minus 2, all over 3 times 2 minus x. Now we need the domain. So the domain is everything in the domain of g that makes g in the domain. So basically what we want to do is we want to take the elements of the domain of g and take out anything that makes g of x equal to 1, right? Because you can't have 1 in the domain of f. So we want to solve 4 over 3x minus 2 not equal to 1, or equals 1, doesn't matter, and we'll take out all the elements. So just to alleviate confusion, let me just do equals 1. So this would mean that 4 is equal to 3x minus 2, which would mean that 6 is equal to 3x, which gives you x is 2. So what we have to do is, from the domain of g, we have to take out 2. So the domain, negative infinity to 2/3, union with 2/3, taking out 2, union with 2, then to infinity. So last example for this video is basically now working in reverse. Given a function, we want to find two functions that when you composite them together, give you f. So write f of x equals square root of 5 minus x squared as the composition of two functions. There are several answers. There are several ways you can go about doing this. Well, what if we say g of x is the square root of x, and we say h of x is 5 minus x squared? Well, then notice that g of h of x is g of 5 minus x squared, which is the square root of 5 minus x squared, which was f of x. And so we now have our composition of two functions. G of x is square root of x, h of x is 5 minus x squared. Now, this is particularly useful when you move on to calculus and you study the chain rule for derivatives. So it's a good idea to practice this now before you get to that point. And so that concludes our study of function operations.